Emma solved the linear equation by graphing. She first determined the intercepts of each line. So she has equation 1, which I've done in blue. Okay, so equation 1 is in blue. It has an x-intercept and a y-intercept of 5 and 5. And we also have equation 2, which has x-intercepts at 4 and y-intercept at 6. So the question asks, write a linear system that Emma could have solved, explain your work, and B, draw the graphs to determine the solution. So I've done B first. I've drawn the graphs, and it looks like based on the two graphs, so the blue graph and the red graph, equation 1 and 2, it looks like the solution is going to be where the intersection is. And looking at that, and this is a relatively accurate graph, and it looks like it's pretty much right on x is 2, y is 3. So that looks like the graph is going to give us that solution. Now, if I want to come up with an equation for these, well, we've done this before. If we have 2 points, so I'm going to start with the blue line, equation 1. If we have 2 points, we can come up with the equation based on those 2 points. Okay, so I can come up with the slope of that equation. So first thing I'm going to do is find the slope. So looking at the slope triangle here, okay, that definitely looks like a slope of 1. So the slope of that line is going to be the change in y over the change in x, which is 5 over 5. In fact, it's negative 5 over 5. So we get that as our slope. Okay, so that's one part of it. And I can see that, so the slope is negative 1, and I can see the y-intercept is going to be at 5. So one of the equations is going to be y equals negative x plus 5. Okay, and then the other equation, we can come up with that other equation. It's going to be, looks like here, if I take a look at this, the red triangle here, the red slope triangle, I've got the slope of the red triangle, change in y over the change in x. Looks like it's going to go down 6 over 4. So that's going to be a slope of negative 3 over 2. And we can see that the y-intercept is going to be at 6. So the equation is y equals negative 3 over 2x plus 6. Okay, so those are two ways we can get the equations. So that's one way we can get the equation. Now, since it's given us intercepts, we could also alternatively come up with an equation by using the intercepts. And it would look like this. So I end up with x divided by 5 plus y divided by the intercept of 5, and that's equal to 1. And that's our intercept form. So this equation is our slope-intercept form, and this is our intercept form as well. These are equivalent equations. I can do the same for the red line. It's going to be x divided by the intercept, 4, plus y divided by the intercept of 6, and that's equal to 1. Okay, so this is our slope-intercept form, and this is the intercept form. And again, those are the exact same equations. And the way we work that out is we just let the x-intercept be the denominator, because that's going to give us a value of 1. So if I take a look at just this part here, that gives us a value of 1. And that makes then this the y portion of this equal to 0 in order for us to get the solution of 1. And the same reasoning can be said for the y. If we divide the y-intercept by 6, okay, so if we put the y-intercept value in the denominator, we get 1. Okay, that makes, since the equation is equal to 1, that means that the x-intercept, the x value must be 0, and that must then be the y-intercept. Now, the last thing we could do, and this is what we're going to end up doing later, is we're going to actually solve this as a system of equations. So we'll solve this algebraically instead of finding the solution on the graph.